am Natalia Czerep. I am machine learning engineer in deepsense.ai, and today I will walk you through our thoughts and our research on 3D renders generation using Gaussian splatting and diffusion models. Let me quickly run through the plan of the talk. So first we will provide some context on how the research even started. Then I will say a little bit about the history of the 3D renders, and then we will jump to how the Gaussian splatting technology even works. For the most interesting part, I think we'll talk about what else besides just renders we can do with Gaussian splatting, and I will cover some our work with scene modification, object addition, and generation Gaussian splatting from just one image. And last but not least, I will tell you our know-how, our tips for working with Gaussian splatting. Of course, I want to mention the team that worked with Gaussian splatting along the way. So big kudos to Krzysztof Dziedzic, to Michał Martyniak, Jan Woś, Adam Maciaszek, and our team lead Jarosław Kochanowicz. In deepsense.ai, we have previously done some projects around 3D rendering with the use of NERFs and Gaussian splatting. Konrad and Marianna talked about them in one of our previous deep talks. So naturally, when the client come up to us with the idea to build a world model, some type of sensor simulation with the use of Gaussian splatting and NERFs, we were all in it. There are successful works from NVIDIA and Waymo, to mention a few, that built a world model on NERFs for the urban scenes. And we were inspired by their research and thought about the use of Gaussian splatting. We thought it would be an even better choice. But it turned out that it is not an optimal playground for this technology. So we got hooked up on Gaussian splatting and we proceed with our internal project. What we observed in the client's project was that the urban scenes, the data is not really suited to showcase the method full potential. The urban scenes are very long. They have moving objects like cars or pedestrians. They are horizontal. And most of the papers talking about Gaussians or NERFs consider 360 object view. And it turned out that there is a reason behind it. So this time in internal project, we went for more technology native data, let's say. So we tried 360 object view and we tried 3D walk through an indoor space. Besides renders, we got creative and we did some scene modifications and renders from text or from 2D images. But before that, I want to give you a short history note about the evolution in 3D rendering for some context. So we started with traditional photogrammetry when it uses triangulation to calculate where the image's feature go, where to put the image's features into 3D space. Then we got the NERFs, so we try to make the neural network learn how the scene looks like. And then people got interested in Gaussian splatting. But before we can train Gaussian splatting, we need a couple of information from the images. So in our experiment, we used CallMap, and it provides the initial reconstruction of the scene or from the object. And basically, what it does, its main task is to perform feature matching. So it extracts features from different images and match them, and then uses triangulation to reconstruct. When we have the point cloud, when we have output from the call map, we can now train Gaussian splatting. But when I say train Gaussian splatting, I mean optimize its parameters. Because in Gaussian splatting, we have no neural network, we have explicit geometric artifacts, some ellipsoids that we can optimize to cover our space to look like the object that we want it to be. So we can change parameters as position, so where the splat is located, how it's stretched, scaled, what color is it, or how transparent it is. One can ask why we even started with Gaussians when there is already research on NERFs, and I will let the numbers speak for themselves. So Gaussians are undoubtedly faster. They are written in this way. That was that, but the visuals are better with Gaussian splatting. What is more, they are not neural networks, so it makes them easy to be modified and controlled. Because of the representation, Gaussians are really easy to be modified, in example with diffusion models. So you can render a scene, render an object, and change its characteristics by just a text prompt. What we did was scene modifications. So we had trained the initial Gaussians of our office kitchen, and then we took the frame out of this render, changed it with instruct pix to pix, and then trained the Gaussian once again, trained the Gaussian splats once again with the new change frames. And we did it a couple of times with multiple frames changed. And as you can see, the colors changed. The lines are more like painting, not so sharp. Yeah. So the next thing we tried to do was adding a new object to the scene. This time the pipeline was slightly different, so we trained the initial Gaussian splats on our scene. Then we prepared the object, so we had one image of our object, and we, using diffusion models, generated different views of this object. We trained a Gaussian splatting representation of the object and merge it to the initial Gaussian of the scene. So as you can see, the thermos on the table can be seen in different angles. It's not disrupting background, so I think it looks really cool. And besides changing the appearance of our kitchen, We also tried other techniques such as Gaussian splatting generation from an image, from the text prompt, or from mesh. There came in handy our experience with diffusion models once again. With the right initial capture, so just one image, we were able to do a Gaussian splatting, so a 3D render of this object. Everything thanks to a smart definition of the loss. As I mentioned before, the interest for the Gaussian splatting technology is growing now. So the tools are not always perfect. The repositories grow in months. So the results out of the box are not great, but with the little code tweaking, our team was able to work with that. So I think it looks very promising that it will only progress in the future. And when we come to an end, I want to share our thoughts and maybe useful tips for working with Gaussians. So first, when everyone is doing 360 views of an object and showing only that, it's because of a reason. It looks the best. Second tip would be if you have a LiDAR data, if you have depth information, use it. It can only benefit your render. When it comes to what we did with the indoor walks, we found out that going around the room is not enough. The best option for us was to go around different objects and capture that. So we can go through, around a table, the coffee machine, or whatever, and merge it with the captures of walks towards a room in different direction. This gave us the most promising results, most photogrammetry-like. We tried working with panoramic 360 cameras, but this type of captures are not Colmap native, so we found it very difficult to work with. As I mentioned, the community is very productive now around the NERFs, Gaussians, and 3D in general. So by the end of our research, we came across a method called SMERF, which models very large scenes in sort of divide and conquer manner, dividing the scene for regions and training submodels, and then merge them. I think it only shows that we can expect much more progress in the next months regarding this technology, and I think we at deepsense, here at deepsense.ai, are very excited to see that. Thank you for keeping up with me and hope you had a good time.